Hi everyone. In this video, we will do the estimation of manhole. Okay, you all know that manhole is a structure which provides access to the sewer lines. Okay, the main purpose of providing this manhole is if there is any inspection needed, if there is any repair or maintenance work needed for the sewer lines. No, through this manhole only, all those things will be carried out. Okay. Now we will start with estimation of the detailed estimation of this manhole. Okay, so here I have written notes for this. I have provided a link in the description. If you want, you can download these notes through the link provided in the description of this video. Okay, now we'll begin with the estimation. Before that, we will just go through the problem. Prepare a detailed estimate of a manhole from the given drawings and general specifications. Okay, there are three drawings given. Okay, it is having a rectangular shape. Okay, we have two sectional elevations. This is sectional elevation along the length of the manhole, and this is sectional elevation along the width of the manhole. Okay, so in the other direction, perpendicular direction, and this is the sectional plan of the manhole. Okay. General specifications related to manhole are foundation and floor concrete shall be of 1 is to 3 is to 6 cement concrete. Whatever the concrete provided here, foundation concrete, it is of 1 is to 3 is to 6 cement concrete. Then brickwork shall be of first class in 1 is to 4 cement mortar. Okay. This manhole is constructed, the walls of the manhole, all the walls of the manhole is constructed by first class brickwork masonry. And for constructing that brickwork, they have used 1 is to 4 cement mortar. Okay. The faces of the wall shall be pointed with 1 is to 2 cement mortar. Pointed means it is pointing work. Pointing work is nothing but it is similar to the plastering work, but in plastering work, the whole surface of the wall we will do the cement mortaring. Means we will do the plastering. But in cement pointing, what happens wherever the joints are there in the masonry wall, only those joints are filled with cement mortar, that is called as cement pointing. Okay, similar to the cement plastering only, but instead of doing uh, cement mortar for the whole surface, we will do the cement mortar only at the joints. That is why it is called as cement pointing. That is the difference between cement plastering and the pointing. In case of plastering, the full surface of the wall will do the cement mortar. Okay, we will place the cement mortar. In case of pointing, only at the joints of the bricks we will place the cement mortar. That is called a cement pointing. Okay, for doing that cement pointing, they have used 1 is to 2 cement mortar. Inside channels and benching floor shall be finished with 20 thick plastering with 1 is to 3 cement mortar. Here benching is done. Okay, some sloped concrete is given. For this over this they have done cement plastering. Okay, over this surface, uh, at all these surfaces they have done the cement plastering. Okay, at these all these surfaces. Okay, they have done the cement plastering, and that thickness of the cement plastering is how much? 20 mm. Okay, thickness of that cement plastering is 20 mm. Okay, let us discuss in detail while doing the estimation work. Okay, now we'll start with the first item of work, that is earthwork in excavation. Okay, earthwork in excavation. So to calculate this earthwork in excavation, see here, uh, the full manhole, you all know that the full manhole will be below the ground level only. Okay, below the ground level only. So here we have the road level. uh, so we have to do excavation work for this much length and this much width and height. From the elevation, from this elevation only we can determine the height. Okay, so length and width of the excavation from the sectional plan we can determine. Okay, the total length of the excavation will be from this point to this point. Okay, and total width of the excavation will be from this corner to this corner. That is the total width of the excavation. And height of the excavation, whatever the total height we get from the road level, that will be the total height of the excavation. Okay. Therefore, total length of the excavation will be how much? See here, inner to inner length from here to here, it is 180 centimeter, 180 centimeter, and from inner surface to the outer surface of the manhole, it is given as 50 centimeter. It is same in all directions. It is same in all directions. Therefore, total length of the excavation is 50 on one side. Okay, 50 on one side plus 60 plus 120 plus 50 on the other side will be the total length of the excavation. Okay, so this total inner length is 1.8 meter. Total inner length of the manhole is 1.8 meter. 1.8 plus 0.5 on one side plus 0.5 on the other side will be the total length of the excavation. Similarly, total width of the excavation 90 centimeters there. 0.9 plus 0.5 on one side plus 0.5 on the other side will be the total width of the excavation. Okay, therefore here you write length of the excavation, L is equal to inner lengths are 0.6 plus 1.2. Okay, 0.6 plus 1.2 plus 0.5 on one side plus 0.5 on other side. Total length that you get is 2.8 meter. 2.8 meter. Similarly, width of the excavation. Clear inner dimension is 90 centimeters. 0.9 plus 0.5 on one side plus 0.5 on other side. You will get it as 1.9 meter as width of the excavation. Therefore, number is 1, length is 2.8 meter, width is 1.9 meter. Coming to the height of the excavation. Okay, from the elevation we have to determine the total height of the excavation. See, from here to here it is given as 20 centimeter. 20 plus 90 plus 100, okay, plus 70, okay, plus 70 plus this 10 centimeter height. This height is 10 centimeter. Will give total height, okay, which is nothing but 0.2 plus 0.9 plus 1 meter plus 0.7 meter plus 0.1 meter will be the total height of the excavation. Same calculation I will write here. It is 0.2 thickness of CC bed plus 0.9 masonry wall height, then 1 meter plus 0.7 plus 0.1. Okay, total height that you get is 2.9 meter. So height is 2.9 meter. Total quantity multiplying all the values, you will get it as 15.43 cubic meter. Okay, so this completes the earthwork in excavation. Next item of work is cement concrete with 1:3:6. Okay, with big brick blast. With brick blast. Okay, just a minute. I'll write here. Okay, I'll write here. Same numbers I will copy here. Okay, number is 1, 2.8, 1.9, 2.9, quantity 15.43 cubic meter. Okay, length, breadth and height I already calculated in the explanatory notes. You can just take the values, okay, from here. Okay, now next item of work is cement concrete 1:3:6 with brick ballast. Okay, cement concrete. So here we have the cement concrete work. Okay, that quantity we have to calculate. Okay, first we will do the calculation for rectangular portion of the concrete. Okay, Here we have two portions. One is one rectangular portion, and we have sloped portion of the concrete that we will calculate later. First we will calculate this quantity of the uh, bed concrete. Okay, foundation bed concrete. Okay, first one, foundation bed concrete. Foundation bed concrete. Foundation bed concrete. Okay, number is 1. What will be the dimensions of the bed concrete? See, whatever the earthwork in excavation dimensions you get, no same dimensions will be there, length and width, but only the change is there in the height. Okay, whatever the length and width for which you are doing the excavation, no, for the same length and same width we have to fill the concrete, no, CC bed. Therefore you just copy the same numbers. 2.8 is the length, 1.9 meter is the width. Height of the bed, CC bed, it is given, how much it is given, 20 centimeter, 0.2 meter, 0.2 meter. Total quantity that you get is 1.06 cubic meter. Okay, now foundation bed concrete is over. So here we have to calculate inside the septic tank. This is sloped concrete provided. Technically it is called as benching. Okay, technically it is called as benching. This concrete is provided rigidly hold in position of the sewer pipes or sewer lines. Okay, to rigidly hold the sewer pipes in position, we will provide this benching or sloped concrete we will provide. Okay, so what we will do is uh, uh, total length of this benching work. Okay, it is provided all along the length of the sewer line. Okay, here we have the sewer line in the plan, you can see that. Okay, therefore total length of the benching is how much, 1.8 meter, 1.8 meter. And total width of the benching, what we can do is we will calculate the total quantity of the concrete by taking as a rectangle. Okay, then we will deduct these portions. Okay, in the deductions, initially we assume that this benching is having total length of 1.8 meter and width of 0. Total length of 1.8 meter all along the length of the pipe, and width of 0.9 meter, this clear dimension. Okay, 0.9 meter it is mentioned here. Okay, 0.9 meter, and height of 40 centimeter. Here this outer to outer length of the sewer pipe is 40 centimeter. Inner to inner, here it is given 38 centimeter. So 40 centimeter. So we will calculate as a rectangle. Then we will deduct these portions. We will deduct these portions. So that we will get the net quantity of the benching concrete. Okay. For length is how much? 1.8. Width is 0.9, and height, okay, 0.4. Okay. Therefore benching, okay, number is 1.8 meter is the length, 0.9 meter is the width, 0.4 meter is 4 meter is the height. Quantity that you get is 0.65 cubic meter. Total if you calculate, you will get 1.71 cubic meter. So in this we have to do deduction. Okay, deduction of the this hollow portion, the hatched portion of the benching work. Okay, okay, by red marking I have done the hatching, that portion we have to deduct. Okay, so here you write deduct upper portion of main channel, upper portion of main channel, upper portion of main channel. Okay, number is 1. Okay, length is 1.8 meter only all along the length of the pipe, that is there, 1.8 meter, length is 1.8 meter. Okay, and coming to the width of the benching, see, width of the benching, it is varying in width. Okay, at the top it is having 0.9 meter width. Okay, at the bottom it is having how much, 0.38 meter width. Okay, so width is, we have varying width. In this case we have to take the average of both the widths. Okay, we have to take the average of both the widths. So means 0.9 plus 0.38 divided by 2 will be the width. B is equal to 0.9 plus 0.38 whole divided by 2. Okay, you will get the answer as 0.64. Okay, therefore 0.64 is the average width. Okay, and height of this portion, this height, actually it is not given in the problem. We have to assume some height. Okay, normally it is almost one third of this pipe diameter. We'll assume it as 15 centimeter. Okay, we'll assume it as 0.15 meter or 15 centimeter, 0.15. So this value is assumed. Okay, if it is given in the problem, whatever the given number you take, otherwise you assume it as 0.15. Okay, so the total quantity that you get is 0.17 cubic meter. Okay, 0.17 cubic meter. See, here we have deducted the upper portion of the main channel. Similarly, benching will be provided for the branch channel. For the branch channel. Okay, we have main sewer line and sub sewer line. For this sub sewer line also, the benching will be provided. Benching will be provided. That also we have to deduct. Okay, upper portion of branch channel also we have to deduct. Okay, next you write upper portion of branch channel. Upper portion of branch channel. Upper portion of branch channel. Okay, number is 1, and length of this branch channel, actually we don't know the length of this branch channel, correct? This length, main channel, you know. Okay, for the full inner to inner dimension of the tank, we have the total length of the main channel. The main channel is running all over the length of uh, manhole. So length you have directly taken as 1.8 meter, but you have to calculate this length. Okay, let us calculate this length. Okay, I'll write a small diagram here. I'll write a small diagram here. Okay, this is the sewer line, inner to inner dimension of the sewer line. Okay, inside sewer, inner to inner dimension of the manhole. Okay, inside this manhole there is a main pipe running. Main pipe running. From this main pipe, a subline is running. Okay, that is branch channel is running. Branch channel, like this it is running. Correct. So we have to calculate this length. We have to calculate this length. Okay, to calculate this length, what you can do is first you calculate this vertical length. This vertical length. Okay, how to calculate this vertical length? See, inner to inner dimension is 0.9 meter. Okay, 0.9 meter. At the bottom of the tank, inner to inner dimension is this, from here to here it is 0.9 meter. Okay, and pipe diameter is 40 centimeter. For this height will be, means this length will be overall dimension 90 minus 40 divided by 2 will give these dimensions. Okay, so here let me call this as a point A. This as point A B. Okay, point A B C. The length BC, length BC is equal to what? This is 0.4 meter diameter of the pipe. Length BC is equal to overall dimension 0.9 minus 0.4 divided by 2. On both sides we have to divide. Okay, remaining length. Okay, divided by 2 will give length BC. How much it will give? You will get it as 0.25 meter. 0.25 meter. So this length is 0.25 0.25. Okay, and remember the normal angle of this sublines from the main line will be 60 degree. 60 degree. Okay, you need to remember this. Normal angle of taking this sewer lines from the main line is around 60 degree. So you apply sin 60 function here. Okay, sin 60 is equal to opposite length BC is 0.25 and we need hypotenuse length AB. That is only the length of the sewer line. This length is the length of the sewer line. Correct? So by this you will get the AB length which is equal to 0.25 divided by sin 60. Okay, 0.25 divided by sin 60. If you calculate the answer, you will get the answer for AB as 0.3 meter. Therefore, length of branch pipe branch channel is how much? 0.3 meter. This length. Okay. This length is how much? Length of branch line 0.3 meter. Okay. Okay. I hope you understood this calculation. 0.3 meter and width. The uh, width of the upper portion of the branch channel will be how much it is? It is given as 20 centimeter diameter. Okay, diameter of the branch sewer pipe is given as 20 centimeter. So we will assume this 20 centimeter only as width. Okay, 0.2 meter, 0.2 meter. Okay, and height of upper portion we will take this same height only. We will assume same height only 0.15. 0.15. Okay, if you multiply, you will get the answer of 0.01 cubic meter. Okay, therefore the total deduction is equal to 0.17 plus 0.01. You will get 0.18 cubic meter. Okay, the total quantity of the concrete by assuming rectangle as we got it as 1.71 cubic meter, and by deducting means total deduction of upper portion of branch channel and main channel we got it as 0.18 cubic meter. You need to the total quantity you have to deduct 0.18, that from that you will get the net total. Therefore net total is equal to, therefore net total is equal to 1.71 minus 0.18. Okay, you will get the answer as 1.53 cubic meter. Okay, you will get the answer as 1.53 cubic meter. So to this cement concrete calculation is over. Okay, the next item of work what we have is first class brickwork in 1:4 cement mortar. First class brickwork in 1:4 cement mortar. Okay, so this manual is made by these walls, masonry walls. Okay, first class brickwork. Okay, the quantity we have to calculate. Okay, and you can see that this manual is having 3 steps. Okay, around up to 90 centimeter height, the thickness of the wall is how much? 40 centimeter. After that, thickness of the wall is reduced to 30 centimeter. Then the next step it is reduced to 20 centimeter. So it has got 3 steps. Okay, so we have to do the individual calculations for different steps of the manual, and we will adopt long wall short wall method. Okay, we will adopt long wall short wall method. Initially I will take the long walls. Okay, in that first step. Okay, in long wall short wall method, for along the long walls calculation we have to do we have to take the outer to outer length. Okay, outer to outer length for the first step. Okay, for the first step, see this clear dimension is how much? 1.8 meter. Here it is mentioned. Okay, 1.8 meter. Outer to outer length means 1.8 plus 0.4 on one side and 0.4 on other side. Okay, from the plan also you can calculate that length. Okay, 1.8 plus 0.4 on one side plus 0.4 on other side. Okay, therefore L is equal to L is equal to 1.8 plus 0.4 plus 0.4. Okay, first step is having 0.4 thickness. What is the answer that you get? It is 2.6 meter. Number of long walls are 2. Correct? Number of long walls are 2. Here one and here one. 2 number of long walls. Length is 2.6 meter. And width of the wall, it is 0.4 meter. 0.4 meter. 0.4 meter. Okay. And height is given. In this elevation only it is given. It is how much? 0.9 meter. Here it is. 0.9 meter. Okay. Quantity that you get is 1.88 cubic meter. Okay. Then similarly we will do the calculation for the second step. Number of long walls are 2. For second step, it is how much? 1.8 plus 0.3 on one side plus 0.3 on other side will be the outer length. Therefore, L is equal to 1.8 plus 0.3 plus 0.3. It is 2.4 meter length. Okay. So 2.4 meter is the length. Thickness of the wall is 0.3 meter. Second step is having 0.3 meter thickness, and we will see the height. What is the height of the second step? 100 centimeter. 100 centimeter, nothing but 1 meter. Okay, it is given 100 centimeter. So 1 meter is the height. Okay, the total quantity that you get is 1.44 cubic meter. Okay, now we'll do the calculation for the third step. Number is 2 only. In third step, be careful. Third step is having total outer to outer length of 60 plus 20 on one side plus 20 on other side. Be careful, don't take 180. First step, at the third step the length has reduced. Okay, it is 60 plus 20 plus 20. Okay, for L is equal to 0.6 plus 0.2 plus 0.2. So 1 meter is the length, 1 meter, and thickness of third step is 0.2, and height of third step, how much it is? 70 centimeter, nothing but 0.7 meter. 0.7 meter. The quantity, if you calculate, you will get it as 0.28 cubic meter. Okay. So this calculation for the long walls is over. Now we will do the calculation for the short walls. Okay. Short walls. Same. First step, second step, and third step. Numbers will be 2 only. 2 only. Coming to the length. Okay. See, from the basic principle of long wall short wall method, along long walls we have to take outer to outer length. We have to take outer to outer length along the long walls. See, along the long walls, outer to outer length we have to take. Already we have taken outer to outer length along the long walls. Outer to outer we have already taken. Correct? For both the walls. Now while doing calculation along the short walls, we have to take inner to inner length. Okay, what is inner to inner length? 90 centimeters, 0.9 meter. Okay, so here the length becomes clear dimension. Inner to inner dimension 0.9, 0.9, and 0.9 for the all the steps. Even for the third step, here in the elevation it is length. Width will be perpendicular to the screen. Okay, it is 90 centimeter only. Okay, so in the plan you can see it is having 90 centimeter. This room. Okay, 90 centimeter only. So inner to inner dimension 0.9 meter only. Coming to the thickness of the wall and height of the wall, it remains the same. Just copy these numbers as it is. Okay, copy the numbers as it is: 0.4, 0.3, 0.2, 0.9, 1 meter, and 0.7 meter. Okay, just copy as it is. And then you calculate the quantity: 0.65 cubic meter you will get the first step. For second step you will get 0.54 cubic meter. For third step you will get it as 0.25 cubic meter. Okay, now we can calculate the total quantity of the masonry work. It's a very simple calculation. Okay, if you properly do the calculation for the long walls, it is very easy to do the short wall calculation. Therefore total first class brickwork in superstructure is 5.04 cubic meter. Okay, 5.04 cubic meter. Okay, so this completes the first class brickwork. The next item of work is cement pointing. Cement pointing, it is nothing but plastering only. I have already explained what is the meaning of cement pointing. Okay, cement pointing means it is like plastering work only. It is provided inside walls of the manhole. It is provided on inside walls of the manhole. Okay, inside walls here. Inside walls of the manhole, that cement pointing will be provided. Okay, and coming to the size of the room, see, size of the room up to 150 centimeter height. Okay, size of the room up to 150 centimeter height is 180 centimeter length, 180 centimeter length, and 90 centimeter width. Okay, then above this room there is a small room where this 180 centimeter length will changes to 60 centimeter and 90 centimeter remains the same. 90 centimeter remains the same. You can see the plan of the room here. Small room over this big room. Okay, so initially what we'll calculate the total amount of plastering work required for this below room, means this lower room. Okay, lower room up to 150 centimeter height we will calculate the plastering work up to 150 centimeter height. For long walls the dimensions are 180 centimeter length and 150 centimeter height. Okay, long walls up to slab, long walls long walls up to slab. Long walls up to slab means here we have the slab, no, up to this level. That is the meaning, up to this level. Sorry, up to this level. Up to this level, below this room is there, no? For this room we are doing the plastering work. We are calculating the pointing work. Long walls up to slab. Number of long walls is 2, no? 1 and 2. Two numbers is 2. And length of the plastering, see, inner dimension is how much? 60 plus 1.2, 1.8 meter is the length. 1.8 meter is the length. There is no width. We will calculate the pointing and plastering work in terms of square meter. Okay, we need to multiply only the length and the height of the wall. Okay, height of the wall is how much? 150 centimeter or 1.5 meter. 1.5 meter. Okay, you will get the answer as 5.4 meter square or square meter. Okay, square meter. Okay, so to this long walls calculation is over. Similarly, we'll do the calculation for the short walls. Short walls up to slab. Up to slab. Numbers is 2 only. There are 2 number of short walls. The short walls. Okay, up to slab. Okay, for bigger room. Okay. The length is 90 centimeter. Inner dimension is 90 centimeter, 0.9 meter. Height remains the same only, 1.5 only. If you calculate the answer, you will get it as 2.7 square meter. 2.7 square meter. Now we will move on to this headroom. Okay, for this portion, we will do the calculation of the pointing work. In that, first one is short walls up to slab. Short walls up slab. Sorry, short left face. Sorry, short left face. Left face. Okay, short left face means this portion. Okay, for this portion we have to calculate total amount of pointing work up to this green line. Up to this green line. Okay, for this face of the wall, short. What is that? Short left face means this face of the wall. This face of the wall we have to calculate the pointing work. Okay, length of the pointing work is 0.9 meter only. From the plan you will come to know. Okay, 0.9 meter. Numbers is 1. Only for the left face we are calculating 0.9 meter is the length. Coming to the height of the plastering. Okay, from here to here 70 centimeter. Okay, 70 centimeter from here to here 70 centimeter plus this thickness of slab will be added. Okay, what is the distance between these 2 points? Up to here, up to this level it is 70 centimeter. 70 plus this thickness of slab. How much here? It is 12 centimeter RCC slab. Okay, here it is 12 centimeter this height. So height of the plastering is on the left side it is 70 plus 12 means 0.7 plus 0.12. Height is equal to 0.7 plus 0.12. 0.82 meter is the height of the plastering. 0.82 meter. So I hope you understood. Okay. This total height of the left face includes clear height of this wall, right side wall, plus this slab thickness. Here slab is not there in this portion, so we have to do the plastering for this portion also, 12 centimeter height also on the left side. On the right side it is not necessary. Slab it is finished surface only. Okay. For on the left side it is 70 plus 12, 82 or 0.82 meter is the height of the plastering. Quantity that you get is 0.74. 0.74 square meter. Now short right face. Right face number is 1. Short right face means this portion. Okay, carefully observe this. Up to this point. Okay, up to this point only. Okay, for slab depth we are not going to do the pointing work. Okay, but because it is a slab. Okay, pointing is done for only masonry. Okay, pointing is done for only walls, not for the slabs. Okay, so here the height will be 0.7 meter. We should not take into consideration of this 12 centimeter thickness. Therefore we are calculating individually for the left face and the right face. For the left face this 12 centimeter will come into picture. For the right face only the clear height 70 centimeter we need to take for the calculation. The length remains the same, 0.9 meter. Okay, 0.9 meter. Here in the plan you can see 0.9 meter length, and height how much? 0.7 meter. Only clear height 0.7 meter. Multiply, you will get the answer as 0.63 square meter. 0.63 square meter. Now the remaining faces. Remaining faces. Remaining faces means, carefully observe. I'll write the remaining faces diagram. Remaining face means this portion. This portion. This portion. You cannot see the wall here. This portion. Okay. Means here in the plan I'll write this portion. Okay, here you can see the length of the plastering for remaining faces. Remaining means these two faces. For this vertical faces we have already calculated. For left face we have calculated, we have done the calculation. For the right face we have finished the calculation. Remaining force means this face and this face, okay, in the section I written here, and height will be how much here? It is 0.7 up to here. Up to here it is 0.7 plus 0.12. 0.82 will be the height, and remaining face length is how much? 0.6 meter and 0.6 meter. Numbers will be 2. Numbers will be 2. 0.6 meter will be the length of remaining faces, and height will be 0.82. Same calculation, 0.7 plus 0.12, 0.82 meter. Okay, I hope you understood the calculation for the remaining faces. Okay, remaining faces also the overall depth will come. Okay, overall depth will come 0.7 plus this 0.12. Okay, you will come to know the length here in the plan. You will come to the height in the sectional elevation for the remaining faces. Okay, the quantity that you get is 0.98 square meter. 0.98 square meter. Therefore, therefore, the total quantity. Therefore, the total quantity. Okay, you add all the numbers. If you add, you will get the answer as 10.45 square meter. Okay, 10.45 square meter. Okay, to this calculation of cement pointing work is over. Okay, the next item of work is 20 thick cement plaster 1:3 in floor and panels. Okay, so here where we will do the plastering work means all the surfaces will be there, no? Here we will do the plastering work. Okay, here we will do the plastering work. Okay, all along the length, all along the length. So length of the plastering is how much? Along the length of the total length of the pipe is 1.8 meter, 1.8 meter. And coming to the width, I'll tell you how to calculate the width. Number is 1. Number is 1. Okay, length is 1.8 meter, 1.8 meter, and width is, it is irregular in nature, correct? The width of the plastering, it is curved in nature. For that, what you can do is you can take this clear dimension as 0.9 meter, 0.9 meter. So to consider this curvature, you can add some lump sum length, means around 30 centimeter extra you can add here. Okay, therefore width is equal to 0.9 meter. Okay, if it is done straight, plastering if it is done straight, but here plastering is curved in nature, so you add some extra of 30 centimeter for curvature plus 0.3. 0.3 means that is additional. Why we have added? For additional curvature, curvature of channel. Okay, that is 30 centimeter. Assumed it is. Okay, assumed. Okay, you'll get the length as 1.2 meter. 1.2 meter. So 1.2 meter. Plastering is also calculated in terms of square meter. So total length of the plastering means all along the length of the pipe we have to do the plastering. Coming to the width, I already explained. 90 centimeter straight plus curvature, as a curvature by taking into consideration of curvature we have added 30 centimeter extra width. So 1.2 meter is the width. If you multiply, the answer is 0.194 square meter. 0.194 square meter. Sorry, it is 2.16 square meter. 2.16 square meter. 2.16 square meter. Okay, this completes the calculation of cement plastering inside the floors and channels. Okay, the next item of work is what? RCC slab including steel, complete work. Okay, so here we have two RCC slabs. So here we have one RCC slab. Okay, and at the top for this portion also we will have one RCC slab. and in that RC slab they have provided manual cover. That portion we have to deduct. We'll deduct later. Okay, but we'll do the calculation for this slab. This is slab. Okay, below right, roof slab of working chamber. Roof slab of working chamber. Working chamber. Okay, number is 1. Coming to the length of slab. Okay, coming to the length of the slab. What is the length of the slab? See, length from here to here we want, correct? So length from here to here we can calculate. So here to here, what will be the length? What is the length? It is 180 minus 60. If you do, you will get this length. How much? 180 is the overall length. In that you deduct 60, so you will get 120. Okay, length from this point to this point. We have some bearing length. Okay, for support purpose to the slab, we will assume it as 0.15. Okay, this is assumed. Okay, therefore length of the slab is how much? 120 plus 0.3. L is equal to 1.2 plus 1.2 plus 0.15, sorry, 0.15. Bearing assumed. Okay, it is not given in the diagram. We have to make assumptions. Okay, so the total length that you get is 1.35 meter. Okay, 1.35 meter. And coming to the width of the slab. Width of the slab, you see in the elevation you can judge the length. Width, you have to go to the plan. You have to go to the plan. Sorry. What will be the width of the slab? It is provided from here to here. Okay, for this portion it is provided. This slab is provided for this portion. Okay, I will just okay, so up to here. Like this it is provided. Okay, slab. Okay, here. So length we have calculated. Okay, length we have calculated already. That length we got it as how much? 1.35 meter. Just a minute. I will just extend this point. Okay, here you will get. So here. Okay, this is the dimensions of the slab. Okay, dimensions of the slab. Okay, length we have already calculated. 1.2 plus bearing 0.15 we have added. Okay, 0.15 we have added length. Now we have to calculate the width. No, for calculating the width, 90 centimeter. Okay, 90 centimeter is the clear dimension. So to provide support for the slab, you have to extend it. We have to provide some bearing. So here also on one side you assume bearing as 0.15, on the other side also you assume bearing as 0.15. So 90 plus 0.15 plus 0.15 will be the width of the slab. B is equal to 0.9 plus 0.15 plus 0.15. So you will get 1.2 meter as width. So here bearing lengths. These are bearing lengths. See, for along the length, bearing is provided on only one side along the length. Okay, the full width of this wall it is taken slab. Okay, for the full width of the slab. So here the bearing is provided on both sides. Okay, so clear dimension 90 plus 0.15 plus 1.15, 1.2 meter. 1.2 meter is the width of the slab. Coming to the thickness of the slab, see how much it is? 12 centimeter thickness. It is having 12 centimeter thickness. Therefore, 0.12 meter is the thickness of the slab. Okay, the quantity that you get is 0.194 cubic meter. Okay, so this to this roof slab calculation of working chamber is over. Okay, next is roof slab of shaft. Okay, this portion here also we have provided the slab, that quantity we have to calculate now. Roof slab of shaft, roof slab of shaft. Okay, roof slab of shaft. Okay, or roof slab of upper room, roof slab of upper room, upper room. Okay, the number is 1, number is 1, and coming to the length and width of the upper room, slab of the upper room. So let me erase this. Roof slab is provided for this upper room. No, here for this room it is provided like this. Okay, like this, the roof slab is provided for the upper room. Okay, this portion is the upper room. Okay, for this like this the roof slab is provided. Okay, coming to the length of the roof slab, it is inner to inner dimension is 60, so we have to leave some bearing, okay, for the support purpose to the slab. Okay, so we will assume around 10 centimeter bearing on both sides. So length is 60 plus 10 plus 10, or 0.6 meter plus 0.1 meter plus 0.1 meter on the other side will give length. Coming to the width of the slab, width of the slab, so clear dimension from here to here it is 90. 90 plus 10 plus 10 means 0.9 plus 0.1 plus 0.1 will give total width of the roof slab. Okay, or else we will consider the larger dimension as length and the smaller dimension as width. Okay, so in the length column we will write this 0.9 plus 0.1 plus 0.1, and in the width column we will write 0.6 plus 0.1 plus 0.1. So L is equal to 0.9 plus 0.1 meter on bearing on one side and 0.1 meter bearing on other side. You will get 1.1 meter as length. Similarly, width is equal to 0.6 meter is the clear dimension. 0.6 plus 0.1 plus 0.1, 0.8 meter. Okay, so length is 1.1 meter, width is 0.8 meter. What is the thickness of the slab given? It is given as 10 centimeter. Okay, 10 centimeter. Here it is not mentioned. Here in this diagram it is mentioned 10 centimeter is the thickness of the slab. So 0.1 meter. 0.1 meter. So multiplying all, you will get the answer as 0.088 cubic meter. Okay. Now we can calculate the total quantity. Total quantity is equal to total quantity of the passive work is equal to, if you calculate the total, you will get the answer as 0.282 cubic meter. 0.282 cubic meter. Okay. Now over this roof slab of the shaft or roof slab of the upper room, one manhole cover is provided. Okay, so you have to deduct the total area or the volume covered by that manhole cover. Okay, it is said that 45 centimeter diameter manhole cover is provided. Okay, therefore we will deduct that manhole cover. Deduct manhole cover. Below, right? Deduct manhole cover. Manhole cover. Number is 1. Diameter is given as how much? 0.45 meter. Okay, 45 centimeter. 0.5 d square by 4. Pi into 0.45 square by 4. Okay, and thickness is 0.1. Okay, multiplying, you will get the answer as 0.016. Therefore the net total, okay, net total after deduction of the manual cover is equal to, net total is equal to the 0.282 minus 0.016. You will get the answer as 0.266 cubic meter. 0.266 cubic meter. Okay. The next item, CI manual cover 42 centimeter diameter including frame. Here you need to just take the number. Okay. The quantity is measured in terms of numbers only. Okay. Per piece calculation will be done. Okay. So here you can write one number. One number. Okay. Then for lastly we have iron footsteps. Okay. Iron footsteps. So in the diagram you can just see the what is the total number of iron footsteps provided. Here it is 1, 2, 3, 4, 5, 6, 7. 7 number of iron footsteps are there. You can just write that number here. 7 number. Okay. 7 number. Iron footsteps are also measured in terms of numbers only. Per piece calculation will be done here. Okay. Per piece calculation will be done. Therefore, iron footsteps number is equal to 7. Okay. So this completes the quantity estimation of manual. So if you have got any doubts in any of the steps, okay, you can just post your doubt in the comment box so that I can clarify your doubts. Okay, I hope you understood this estimation of the manual. Okay, thank you.